a property of cardinalities in general. Something has a cardinality at least as big as any subset. So we're just going to check this. So by contradiction, we would suppose there is a bijection from n onto the irrationals intersect 0, 1, and we're going to show, we're going to conclude that the bijection is not onto, which is the contradiction. Okay, so that's the strategy. Now, what I'm going to use for this strategy is the fact that every irrational has a decimal expansion. Okay, now, in fact, every real number does, but we'll just do the irrationals. A few things that you may not have thought about with decimal expansions and why you have to be a little bit careful here, right? But decimal expansions are not unique. Okay, so for example, who can tell me 2 decimal expansions of the number 2? Well, one is obvious, right? What's the other decimal expansion for 2? Yeah. Equals 1.9999. Okay? If you don't believe it, tell me what number is in between those two. We know about density of the rational numbers, right? So there should be something in between those two. What would its decimal expansion be? 0, 0. It's not possible to get a decimal expansion between those two. So the reason why this is important is that we have to be a little careful with 0s and 9s, right? Because you can have different decimal expansions giving you the same number, and this is the only situation in which that happens, okay? So again, if we're thinking about 1 to 1 and onto, we want to be a little careful that, if we have 2 different representations for the same number, we might get messed up, right? Because for example, if we took these to the same thing, we might think, oh no, this is not 1 to 1, but in fact those are the same number, so it is 1 to 1, right? Okay, so everything has a decimal expansion, every real number has a decimal expansion, right? So what we're going to do is we're then going to start, and we're between 0 and 1, so there's going to be nothing in front of the decimal place, all right? So I'm going to write down my bijection, or at least a little bit of it, okay? So 1 has to go to something with a decimal expansion. So okay, so we're using double subscripts now. That's something you might need to get used to. You will need to get used to if you take any more math classes, especially in analysis. Don't know if you all are familiar. Have you seen these in calculus? I don't remember if these actually come into calculus. Okay, you definitely see them in matrix algebra. Yes, exactly. Yeah. Okay. So we're using them in a slightly different way here than you would have seen them. So 1 goes to, this is the decimal expansion, and so then what I'm using the subscripts for here is to indicate what natural number I'm coming from. Okay, so this is going to be A21, A22, A23, A24. And so 3 is going to go to A31, A32, A33, A34. Okay, and this continues. Okay, again, everybody understand what the subscripts are. The first entry in the subscript tells you that it's the image of that natural number there. And the second one tells you where it is in the decimal. Okay? So I'm supposing now I have a bijection. Okay, that looks like this. How do I find something that's not on there? How do I find something that 1 doesn't hit? How can I be sure that it's something that 1 doesn't hit? What do I need to do to this decimal? Just change it somewhere, right? Okay, so I'm going to now exchange A11 with a different number not equal to 0 or 9. Those are the scary ones I want to stay away from, right? Now, so I'm going to start constructing a decimal that's not hit by this function, so it's not onto, okay? So let's call that one B1. Okay, so I'm constructing my decimal, that's B1. Okay, so since B1 is different from A11, and I'm avoiding the problems with zeros and nines, I know that already 1 can't hit this number I'm making up here, right? Okay, now I don't ever want to change this one. I want to move on to the next one, right? And I'm going to look in here and I say, well, okay, I'll just change that one. In the same way, it's different, right? And so this thing I'm constructing, now I know 2 can't go to it because I've changed this. So this thing I'm making is not equal to this decimal. So 2 can't go to it. And now you get the idea. This is called a diagonal proof. Okay, and there are various kinds of diagonal proofs. Okay, I just now changed the third one to something new. And so then the number b equal point b1, b2, b3 is not in the image of the function. So this contradicts the assumption that it's one-to-one and onto function. It's not one-to-one. And in fact, there's a modification of this kind of argument that says that if you take any set and you take the set of all subsets of that set, then the cardinality of that is strictly bigger than the cardinality of the set you started with. So there are actually infinitely many different cardinalities. For every cardinality you pick up, you can always find a bigger cardinality. Okay, using that method. And there are all kinds of strange questions about, whether these cardinalities or those cardinalities are equal. But basically, what you need to know, especially, again, this is important in mathematics and computer science because there are things like NP complete and, and uncountable things. Obviously, you're not going to target with a computer, right? Because computers only do finitely many things. So there's no way you're going to be able to handle something uncountably infinite. Okay, so those are the cardinalities. All right. Any questions about that? Okay, now we have a few minutes left and we're going to talk about and then do the SAIS. So the deans have been asking questions about this. So I'm going to ask you guys, so I think we have like 35% here who have done them so far. I don't know who does them, okay? I just know what the percentage is. So number one question, and feel free to answer, your grade does not depend on this, and I'm going to give this information, this is just a poll, right? So, and I got interesting responses from other classes, right? But why do you not do SIAS, the student evaluation forms? Just curious, other than not being forced to.
You get your computer and get distracted by Facebook.
Blame it on Facebook, okay. Any other reasons? You just don't get it? Yeah.
For me, any reason I wouldn't do it, last semester I was pretty good about doing all of them, but any reason I wouldn't do it would just be more like, I'm just prone to forgetting. Like,
right.
I'll start working on homework,
right.
or lab or something, and I just forget about it.
Right.
I got an offer in my technical writing class, the last class we're having.
Right.
Everybody gets 1 point of extra credit if we sit down and do all the SAIS for each of our classes.
Yes, and here's the thing. That's not actually allowed. That's part of the problem we're wrestling with, and I'm trying to provide arguments against it, because the easiest thing would be just to have you guys bring in, evidence that you've done this and give you like a point, But the provost doesn't like this strategy, although, like I said, I'm having discussions with the dean about why not. If it gets like 100% participation, then why is that bad? Okay, so anyway, but we're not strictly, don't tell me who it is, I don't want to know, okay? But anyway, I won't do that. But what we are going to do is, first of all, does everybody have a device that connects to the internet? Okay, first of all, how many, anybody, and if you want to be known or not known, anybody who's already done it gets to leave. And you don't get any points. At least I get to see how responsible you are as you walk out. Okay, so, oh, and homework, yes, let's get that. Okay, and anybody who did not do it, and like I said, I think it was like 35%. If you don't have an internet-capable device, and be truthful, then you get to leave too. Okay, otherwise, I want you to pull out your device and go to Blackboard and go to the link that I provided in the message that I sent to you guys about this.
I don't have a laptop, just this. I'll do it.
Phone will work, phone will work.
But I gotta type out how long it is.
Yeah,
I didn't staple it, is that?
I'll manage. Okay, so,
Need that copy? I just made my stuff look better than this.
okay, all right, that's fine, that's fine. Okay, so, some of you guys are sneaking out. I don't know whether.
Today, I swear.
All right. Yeah, so those of you who are here and being honest about having a device and not having done it. So there is a thing on, and you'll be able to get this done in 5 minutes by the end of the class, okay? So I provided a link on Blackboard for you to use, okay? And I will leave so I don't give you the intimidating evil eye. I did provide a link. Go to the link, and since you have time and since you're there, don't just do it for this class. Do it for